Probability. There are two main types of probability that we will be talking about. Theoretical probability and experimental probability. So theoretical probability is a method of determining how likely it is that an event will occur. The probability of an event ranges from 0 to 1, where 0 means the event absolutely cannot occur, to 1, where the event absolutely will occur. And you're somewhere on the spectrum in between. If you have a probability of 1/2, that means it's equally likely to occur as to not occur. You can express it as a fraction, and probability is the one time where you're not technically required to reduce the fraction, as a decimal or as a percent. So when all outcomes are equally likely, the theoretical probability that an event A will occur is the probability of A. So we use like a function notation there, equals the number of outcomes in event A, so the number of favorable outcomes, over the total number of outcomes. The theoretical probability of an event is often simply called its probability. So here's our first example. You roll a 6-sided die whose sides are numbered 1 through 6. Find the probability of rolling a 4. Well, on a die, there's only one 4 out of 6 total sides, so it's 1/6. Probability of rolling an odd number, well, the odd numbers on a die would be 1, 3, and 5. So that's 3 chances out of 6, so you can leave it like that, or you can reduce it to 1/2. Letter C, probability of rolling something less than 7. Well, the die only goes from 1 to 6, so that's 1 out of 1, or just 1. Sorry, I guess I should say here 6 out of 6. All 6 sides are less than 7 out of the total 6 sides, which equals 1. Every number on the die is less than 7. Number 2, you put a CD that has 8 songs in your CD player, or you could think of it as an MP3 player, and you've loaded the newest album on there. You set the player to play the songs at random. The player plays all 8 songs without repeating any song. What is the probability that they're played in the same order as listed on the album? Well, there's only one way that can happen. You play all the songs in the exact order they're listed on the album. So there's only one favorable outcome. What we need to think about are the total number of outcomes. Well, there's 8 options for the first song that the CD player could play, 7 for the second, 6 for the third, and so on all the way down. So it's 8 factorial. 1 divided by 8 factorial, which would be 1 over 40,320, or if you go to a decimal, that is approximately 0.1234025. Experimental probability is when we actually conduct an experiment or survey and find out the total number of people who say something in a survey, or the total number of times heads comes up if we're flipping coins, and then we put that over the total number of times we attempted it. So for a given number of trials for an experiment, the experimental probability that an event A will occur is the number of trials where A occurs, so the favorable outcomes, over the total number of trials. A trial of an experiment can be something as simple as a flip of a coin, or a survey where each response is a single trial. So in this first example, we're helping to choose a mascot for a new school. 200 students were asked to pick their favorite from the following options: falcon, lion, and panther. So this table shows us the results. That 39 said falcon, 76 said lion, 85 said panther. They want the experimental probability that a randomly chosen student prefers the lion. So the probability of a lion. So we come here to the table and we see 76 people said lion out of the total 200 students that were polled. So it's 76 out of 200. You can leave it like that, or you can reduce it by 4. 76 divided by 4 is 19. 200 divided by 4 is 50. If you prefer the decimal, it's 0.38. Or as a percent, 38% of those polled chose lion. Number 4, the blood types for a sample of donors at a blood drive are displayed in the bar graph. Find the experimental probability that a randomly selected blood donor would have blood type O. The universal blood type, they call it. So there's 22, so the probability of O, 22 out of, we need to determine the total. So if we add them all up, 22 plus 21 plus 5 plus 2, we get 22 out of, well, 22 and 21 makes 43, plus 5 is 48, plus 2 is 50. So 22 over 50, or if you reduce by 2, 11 over 25. As a decimal, that's 0.44, or as a percent, 44% of the blood donors were type O. So that's the basics of probability. This is just the intro to probability. We will be looking at more complicated versions later, but this is just a quick reminder that there's theoretical probability, where we just talk about how likely it is something will happen, and there's experimental probability, where we actually do the experiment or survey and find out how many times it happens. So now you've got a couple of pages of practice problems to try, and then we can move on to some more interesting and challenging examples.